Have you ever stopped to think about the scale of the universe? Within the Milky Way alone, there are around 400 billion stars, each potentially surrounded by numerous planets, contributing to a staggering number of celestial bodies in just our galaxy. And yet our galaxy is merely a drop in the cosmic ocean, with current estimates suggesting there are over 2 trillion galaxies within our observable reach. This vast collection of cosmic structures makes up the universe as we know it, but it represents only what we are able to observe. So, what could exist beyond this boundary? Is there a boundary at all? These questions challenge the limits of our current scientific understanding and probe the very nature of existence itself. As we push the limits of our telescopes and the capabilities of our computational models, we find that answering these questions requires not just data, but also a deep consideration of physics and cosmology. In this episode, we're going to unravel the science and speculation surrounding what might lie beyond the observable limits. We'll examine the leading theories in cosmology, from the concept of an infinite universe to the idea of a multiverse, where our universe is just one of many. We'll also discuss the implications of cosmic inflation, dark flow, and the potential of undiscovered phenomena that could redefine our place in the cosmos. Prepare to expand your understanding of the universe as we explore the most profound mysteries in space. Welcome to SpaceLab, where we bring the universe to you. In our cosmic voyage, we begin by contemplating the vast expanse of the observable universe. This sphere encloses every star, galaxy, and nebula that we can potentially observe. It's defined not by physical boundaries, but by the finite speed of light and the finite age of our universe. Think of the observable universe as a bubble of history, a cosmic time capsule within which we can study the light that has traveled across eons to reach us. This bubble expands with every second, revealing older light from farther away. Yet this light is from the universe as it was, not as it is, a ghostly image of the past. Because of this, the edge represents the most ancient light that has ever reached us, a boundary beyond which lies the unobservable, the unknowable, the regions of space-time from where light hasn't had enough time to complete its journey to our telescopes. What about the region beyond the observable edge? If the universe is indeed infinite, consider the implications. An endless sea of cosmic phenomena, stretching beyond imagination. It's a realm where the numbers fail us and where infinity becomes more than just a mathematical concept. It becomes a reality. Within this infinite expanse, every conceivable cosmic event has potentially occurred countless times over. The laws of probability suggest that far beyond our observable limits, there could be duplicates of our galaxy, our planet, or even ourselves, living out their existence in the vast cosmic landscape. But infinity is a tricky concept. It's both exhilarating and daunting, as it defies our human experience, which is always bounded by limits. Now imagine instead a universe that is finite, like the surface of a hypothetical cosmic balloon. This analogy is not just a flight of fancy, but a serious proposition to explain the nature of the cosmos in which we reside. In this universe, you might begin a journey heading off in one direction, and, after a lengthy voyage, find yourself arriving right back at your starting point. This would occur without the need for you to traverse any barrier or edge, an experience that defies our everyday understanding of travel on Earth. This is a closed universe, one that is finite in size, yet paradoxically boundless. It's akin to the two-dimensional surface of a three-dimensional sphere. At first glance, this notion seems contradictory. How can something be both finite and without borders? Yet this is the very essence of our cosmic balloon analogy. It aids in visualizing a universe that is unbounded in such a way that you could journey forever without hitting an invisible wall, all the while actually traversing a finite amount of space. The analogy also brings to light the challenging concept of space curvature. Within this model, space is not a flat expanse but curves back upon itself. A straight line, an idea so fundamental to our understanding of geometry, is no longer straightforward. Instead, what we perceive locally as straight lines are, on a grand cosmic scale, actually curved. This curvature is not an illusion, but an intrinsic property of the universe, one that could potentially fold the vast cosmos into a shape that is both comprehensible and navigable, all without the need for an edge or an end. When we consider the expansion of the universe, the picture becomes even more fascinating. The galaxies are not simply drifting apart within an inert cosmic space. Space-time itself, the very fabric of our universe, is stretching and expanding. This expansion isn't a trivial matter. It's a dynamic process that carries whole galaxies with it, as if they were mere flotsam on the surface of a swelling ocean. This expansion is not happening at a leisurely pace. It's accelerating. The implications of this acceleration are profound for our understanding of the cosmos. If this trend continues, the galaxies that we can currently observe will one day be so distant that the space expanding between us will stretch too far. Their light, which once traveled across the cosmos to reach us, will no longer be able to bridge this ever-widening gap. In a very real sense, our observable universe is shrinking, not in actual size, but in terms of what we can see. It's as if we're on an island of light that is becoming increasingly isolated in a darkening cosmic ocean. The fate of these galaxies is similar to that of ships in ancient seafaring maps. As they sail off, they don't fall off the edge of the world, they simply move beyond the horizon, beyond the cartographer's drawn borders, and out of sight. In the same vein, galaxies crossing our cosmic horizon disappear from our view, not because they plunge into some cosmic abyss, but because they have sailed beyond the reach of our perception. As they do, they take with them the secrets of their stars and the stories of the space they occupy, leaving us to wonder and to study the faint whispers of light that managed to reach us before the inexorable stretch of the universe carried them away into the silent depths of the cosmic sea. And what of the cosmic light horizon? This boundary is the ultimate limit of our observational reach, the divide between the known and the unknown. Beyond this horizon, there could be wonders or terrors beyond our wildest imaginations. There may be regions where the fabric of space-time is so radically different that our physics cannot describe it, or perhaps where entirely different stories of cosmic evolution have played out. We may speculate about the nature of these regions, but until we can observe or interact with them, they remain shrouded in mystery. This is the frontier of our cosmic knowledge, the threshold beyond which lies the terra incognita of the universe. And finally, let's entertain the breathtaking possibility of a multiverse. The idea that our universe might be just one of an infinite number of universes, each with its own distinct properties, is a concept that has moved from the realm of science fiction to the table of serious scientific discussion. In this multiverse scenario, the edge of our universe would be akin to the shore of an island in an archipelago, surrounded by other islands, other universes, with potentially different laws of physics, different histories, and maybe different forms of life. The multiverse theory extends the concept of cosmic horizons into a new dimension of thought, suggesting that our observable universe is just a tiny patch in a grand quilt of universes. Each universe would be a bubble in a cosmic foam, expanding within a larger multiverse that is unfathomably vast and varied. This multiverse could be the product of cosmic inflation, a rapid expansion following the Big Bang that could have created a plethora of universes, each one a separate and distinct pocket within the fabric of reality. In wrapping up our exploration, we see that the edge of the universe is not a simple nor a singular concept. It is a term that bends under the weight of cosmological theories and the limitations of our understanding. It's a frontier of not just space, but of time and knowledge. As our instruments peer further and our theories grow more refined, we inch closer to the answers that, for now, lie just beyond our grasp. The edge of the universe, as we've seen, is not an edge at all in the traditional sense. It is the threshold of the observable, the boundary of our cosmic bubble, and possibly just one of many boundaries in a much larger, grander cosmos than we have ever dared to imagine. In this grand cosmic landscape, our place is both humbling and special. We are the explorers of this vast universe, armed with curiosity and technology, pushing the boundaries of what we know and expanding our horizons. The questions of whether the universe has an edge, how it might look, and what lies beyond are among the most profound questions we can ask. They remind us that the universe is a place of wonder, a place where the limits are not of the cosmos itself, but of our current scientific reach. Remember, each step we take in understanding the edge of the universe takes us not only further into the unknown, but also deeper into ourselves, into the essence of what it means to be curious, intelligent life seeking to understand the great expanse of existence. The universe's edge is a concept that transcends physical space. It's where our imagination and our science coalesce, pushing us to think bigger, to explore further, and to dream of the possibilities that lie at the very frontier of the final frontier. And so, we are left to ponder, to research, and to wonder. As we stand on this cosmic shoreline, gazing out at the vast ocean of reality, we acknowledge the edge of our observable universe, and we dream of what lies beyond. It's a quest that humanity will continue, as long as we gaze up at the stars and wonder about our place among them. If we were to transcend the cosmic light horizon, we would be stepping into the ultimate unknown, a region untouched by any photon that has ever reached Earth. This is the domain of speculation, where scientists use the most advanced theories of physics to make educated guesses. One such theory suggests that the universe at large scale looks the same in all directions and at all locations, a principle known as the cosmological principle. If this holds true, then beyond the edge, we would expect to find more of the same. Vast cosmic structures, galaxies, and possibly even whole superclusters, much like the ones we can observe from Earth. It implies an endless, uniform tapestry of matter and energy, uninterrupted by the horizon of our sight. However, this is not the only possibility. Some theories propose that the universe could be anisotropic, meaning that its properties vary with direction. This could lead to a large-scale structure that is very different from what we see locally. Maybe there are regions where matter is more densely packed, or where the laws of physics operate with different constants. There might be areas where time dilates in ways we cannot comprehend from our standpoint within the observable universe. These variations could give rise to entirely different evolutionary histories of stars, galaxies, and life, if such a concept could even exist there. Astrophysicists also entertain the concept of dark flow, which suggests that there are gravitational forces beyond the observable universe pulling galaxy clusters in a common direction. This could indicate the presence of structures outside our observable realm, so massive that they significantly affect the motion of objects within our own universe. The theory of cosmic inflation, proposed by physicist Alan Guth and others, provides another perspective. It posits that during the universe's first fraction of a second, space expanded exponentially, stretching far beyond the small patch we can observe. If inflation is correct, the true universe may be so vast that entire regions never communicated with each other because they expanded faster than the speed of light. In these unobservable regions, the laws of physics might be drastically different, leading to a multiverse where each bubble universe has its own set of physical constants and properties. Moreover, string theory suggests a landscape of possibilities, where different regions of a higher dimensional space correspond to different laws of physics. Within this framework, our universe could be one of many three-dimensional brains, floating in a higher dimensional space, each with its own set of laws and constants. If we could somehow break through to this higher dimensional space, we might encounter a staggering diversity of universes, each with its own unique characteristics. Tackling the multiverse from yet another angle, the many worlds interpretation of quantum mechanics proposes that for every quantum event, the universe splits into a multitude of parallel universes, each representing a different outcome. This interpretation would imply that beyond our observable universe lies an infinite number of universes where all possible histories and futures occur. But perhaps the most mind-bending hypothesis is the idea that our universe is but a simulation within an incomprehensibly advanced computer system, operated by entities in a parent universe. If such a scenario were true, venturing beyond the edge of our universe would mean uncovering the underlying code or machinery that simulates our reality, a concept that stretches the fabric of our understanding of existence itself. In the end, the question of what lies beyond the observable universe remains one of the greatest mysteries in science. Each hypothesis brings its own set of philosophical questions about the nature of reality, existence, and the limits of human understanding. We are left to marvel at the potential of what might lie beyond the edge, the strange, the exotic, and the utterly unimagined. As our journey through the cosmos comes to a close, we're reminded that the universe is far more vast and mysterious than we can ever truly comprehend. Today, we've ventured to the very edge of the observable universe and peered into the abyss that lies beyond, where the light of known galaxies has not yet reached us and where the secrets of the cosmos lay hidden. As we've ventured together to the very edge of the observable universe, we've peered into the abyss that lies beyond, where the light of known galaxies has not yet reached us, and where the secrets of the cosmos lay hidden, veiled in darkness and silence. We've explored the staggering possibilities of an infinite universe, where the cosmic light horizon is not a boundary, but simply a mark on a continuum that stretches on without end. The tantalizing concept of a multiverse has unfolded before us, a landscape where every conceivable possibility becomes a reality in its own separate realm of existence. We've grappled with enigmatic theories that push the boundaries of space, time, and our imagination, challenging us to rethink our understanding of the universe and our place within it. While we may not have all the answers, we stand on the precipice of discovery, our gaze fixed on the horizon of knowledge, equipped with ever-improving technology and an insatiable desire to know the unknowable. Every hypothesis, from the cosmological principle to the simulation hypothesis, serves as a testament to human curiosity and our relentless pursuit of understanding. As our journey through the cosmos comes to a close, we're reminded that the universe is far more vast and mysterious than we can ever truly comprehend. Yet, we continue to search, to hypothesize, and to dream. Each star, each galaxy, each enigmatic particle whispers a part of the grand cosmic story yet to be fully told. So, we would like to ask you what you believe lies beyond the observable universe. Which of these theories makes the most sense to you, and which do you think is most likely? Could there be an endless sea of galaxies, an extraordinary array of universes, each with its own laws? Or are we in a simulation, with its edges just beyond our reach? If you enjoyed this journey into the depths of the cosmos and the boundless potential of theoretical physics, please leave a like. Your support helps us to bring more content like this to you. Thank you for joining us at SpaceLab, where the universe is not just out there, it's a part of us, waiting to be discovered. Until next time.